let's see if we can calculate the instantaneous voltage that a generator produces just using geometry. So here's our generator over here. We have a north and south pole, and we have our lines of force running between them, and then we have a coil of wire here that we're going to spin inside of this magnetic field here. So if we cut this in half, this is it, looking at the end of it here, and these dots here represent our wire, just cut in half there. So let's start here at 0 degrees here, okay? This is A. Now these vectors here, A to D, B to E, and C to F, those are all the same size as the maximum voltage here, from O to C here, okay? So these represent our max voltage, and voltage is induced in a conductor when lines of force are cut, and the voltage depends on the number of lines cut in a unit time. And these lines, A to D here, B to E and C to F, they represent the direction that the conductor is moving at that instant in time, okay? So start at A here, and A is moving this direction here. Well, no lines are being cut. It's in parallel with these lines here. No lines of force are being cut. We have 0 voltage. Same over on this side. This would also be 0. Let's go up to 90 degrees, okay? So at 90 degrees, here's our vector going this way. We're cutting the maximum number of lines of force going this way. So that's going to be our maximum voltage. In this case, we're saying it's going to be 170 volts max, okay? Now, if we go to B here, okay, now B, from B to E, that's the direction that the traveling at that instant in time. And if we put a right triangle here, we can go from B to G and G to E, and that represents this angle here. Now, we know that this angle here is 170 volts. We said it's the same as the E max here. So we can calculate what this this side here, this side A is going to be, okay? And that's going to be this side down here, okay? So we know that this angle here, this hypotenuse is going to be 170, and let's just say let's start with 30 degrees here. So if we have 30 degrees and 170 volts on the hypotenuse here, so with geometry, what we'll do is we can go down here, if we say this is 170, we have 30 degrees. Now we can just put two triangles together. 30 and 30 makes 60, and of course these sides are going to be 60 and 60. So we're going to have 170 volts all the way around, and half of that is going to be 85 volts here. So this line here at 30 degrees is going to be 85 volts, okay? So if we take 170 times the sine of 30 degrees, it's going to be 85 volts. So at 30 degrees, then we produce 85 volts, okay? Instantaneous voltage of 85. What happens if this angle is 45 degrees? Well, here's a 45 degree triangle. Now we know from Pythagoras' theorem that side C here is equal to A times the square root of 2. And so A over here is going to be equal to C divided by the square root of 2. Or we could say that A is equal to 1/2 C times the square root of 2, okay? 1/2 C is 85, and we times that by the square root of 2, which is 1.414, and we get our 120 volts, okay? So, we got 0 volts here. If this was 30 degrees, we'd have 85 volts. If it was 45 degrees, we'd have 120 volts. And up here we have 90 degrees here, and that's going to be our max voltage, 170 volts. And it just depends on how many lines of force we're cutting as we spin this through the magnetic field there. So that's all there is to calculating the voltage here on inside the generator, and we just did it with geometry. Anyway, thank you.